Hi everyone, this is Makridis. I am a PhD candidate and researcher in the University of Piraeus. Today we will see a part of our work that we have done with my colleague Mr. Makridis from UPRC and Bank of Cyprus for the pilot 5B of the feeder project. In this pilot, we develop a business financial management tool to assist small and medium-sized enterprises in managing their financial health. The main innovation of the pilot lies in the provision of automated predictive assistance to SMEs based mainly on AI and data models about how to plan future liquidity needs and fulfill their obligations. The main stakeholders of the pilot are Bank of Cyprus and University of Piraeus. Specifically today, we will pass through the process needed to present the second microservice of this pilot, namely the cash flow prediction engine, which aims to accurately predict the cash inflows and outflows of the given categories of each account of an SME. Objective and nature of the task implied that the necessity of transforming the data into time series representation, enabling the experimentation with various general forecasting models or prevalent deep learning models. If we think that we have finally used the DeepAR model from the Gluon time series library, we can assume that this notebook is a tutorial also of how someone can use DeepAR working on use cases like this. So the Python code of this video will be available in the FinTech marketplace along with other resources, and all the links will be available in the description of this video. Now let's start with presenting an ADA, an explanatory data analysis. So to do this, you have firstly to import some libraries that we will use throughout our notebook. These libraries include pandas, NumPy, scale-learn, and other libraries used for data analysis and preprocessing, and some tools like and frameworks like Matplotlib and Seaborn for visualization. So we should mention at this point that we are using Python as a programming language. However, if someone is not familiar with Python, he can just comprehend the process and the steps and apply them leveraging other tools. Given that, to the best of knowledge, there is an open source dataset including SMEs transactions, we utilized the dataset that has been provided by Bank of Cyprus, composed by tokenized transactions attributes of the bank clients. So this data mainly includes customer and account data and approximately 3.5 million data entries, transactions from the years 2017 to 2020. So let's start by first loading the data to a pandas data frame. Given that the data is quite, let's say, big file, then it should take some seconds in order to be loaded. We can have a sneak peek at the first 5 rows of the data by selecting the head of the data frame. The data that are already categorized from other components. That means that we have also applied these features that are not given by the Bank of Cyprus, are created but by another tool that we are building within the FinTech project. And so we can also check what type of characteristics of the transactions someone can get from the system of a bank, including account keys, transactions, transaction code, of course the amount, and other useful information. The first thing that someone can use when we have some data is to check if we have missing values or the correlation between the features, if we can get any useful insights, or the correlations between the features that include missing values in order to see the process that the missing values are being generated. So here we have an image where someone can see the presence of missing values, where with the white color it means that each feature vertically includes missing values. And This is also a heat map, the correlation between the features regarding their missing values. So here we can see that, for example, that here if it's an interbank transfer indicator is totally correlated with contactless indicator. That means if we have a missing value here, then the same should be applied. We should find missing value at this feature as well. When we have negative values of correlation, that means that if we have a missing value somewhere, then in the other feature the missing value should be filled with something. So let's finalize the data analysis and jump into the cash flow prediction. So why cash flow is important? Besides revenues and comprehensive budgeting, having an efficient cash flow prediction mechanism is essential for the financial success of an SME. An engine that predicts the future inflows and outflows derived from historical incomes and spendings allows the user to set budgets per category and allocate available sources. Furthermore, it should be noted that in terms of predictions, the prediction time frames may be over a quarter of a year, 3 months. These predictions aim at improving the internal financial monitoring of an enterprise and its various inflows and outflows, while also enabling professionals to ensure the business continuity of their clients. At the same time, given that the exam time series case is a multi-step ahead prediction task, it should be mentioned that for time series forecasting, when you have we have to predict look ahead horizon gets proportionally harder as this horizon widens. That means that we have let's say aggregated errors from as this horizon is getting bigger. In our case, as we mentioned, we will use the DeepAR model. The DeepAR model has the ability to learn seasonal patterns from the given coverage, which strengthens its forecasting capabilities. We will elaborate this further as we go on. So for this analysis, we will use only the amount of the transactions and the date of the transaction, as the amount represents the normalized original amount in respect of the currency. And here it's a plot of the distribution of the amount that is included in our data set. Also, we will have some other transformations that is quite common when we have to do with data. So we will create 3 new features, that is the month, the day of the month, the day of the week of each transaction. And it's quite interesting to see all these statistics and to get some insights regarding the distribution of one account and not the whole data set where many accounts are present. As we will see later, we will use the account that has the most transactions in our data set. This is some statistics of it's also created a new data frame, and this data frame only includes the transactions that this specific account has made. So this is some basic statistics, including the quantiles, the mean and maximum values, and this is the distributions of this account transactions. Again, it's quite skewed, and again we can see it here some outliers. So first of all, we can see how this money, let's say, is distributed along the different categories of transactions. So this is most of these accounts transactions are income or transfer transactions. There are some uncategorized, and the other transactions includes payroll, professional fees, supply banking expenses, and office expenses. It's quite interesting also to see how these transactions are distributed along the month, the day of the month, and the day of the week, the features that we have created earlier. You can see some plots regarding the distribution of this account per category and per month. As you can see, you cannot get any useful insight from the income nor from the transfer, but we can see other stuff like that the professional fees only happens during December. Bank expenses mostly happens the 3rd, the 5th, and the 12th month of each year. Same things, we can check the same things regarding the day of the month. Here is uncategorized expenses. I don't happen every day, and supply expenses, not interesting. This is also bank expense that it happens mostly the 5th and the 10th day of the month. Okay, the same is for the day of the week. So let's move on. Let's see in our data sets, the whole data set again, and not the specific account data set. This is the accounts, the IDs that have the most, let's say, transactions in our data sets. So we used this one, which is the one with the most transactions in its notebook. Let's go to the most, let's say, interesting part of today's video, which includes the DeepAR model, the one that we have utilized to do our predictions. So, DeepAR model is a deep learning approach implementing an RNN-based model, a probabilistic RNN-based model, close to the one described here in this paper, and it's used, in our case we use the one provided by the Glon time series. DeepAR applies a methodology for producing accurate probabilistic forecasts based on training an autoregressive RNN on many related time series. That means that we can feed this model with many time series, and it can, let's say, extract even latent information regarding the correlations and any possible latent links between the different time series. So it is well known that RNNs have the concept of memory. That's the reason that they are mainly used for time series forecasting tasks, as we need history information in order to predict the future behavior. In our case, the RNN predicts the mean and the variance of an underlying time series, and then it's coupled with Monte Carlo simulation in order to present the results as a probabilistic distribution. The main architecture of the DeepAR is here. That means we have the time series and other covariates, the month, the day of the month, day of the week, the features that we have created earlier. Also, we can use other features like the number of employees of each SME, if it's a holiday or not, and any other useful information, again represented as a time series, in order to predict this value. So we are getting the previous value along with the new covariates, and this is fed to an RNN network, where we can use the hidden state and the new information in order to get the new hidden state of this time series. And then there are two density networks. The one is predicting the mean value of the time series. The second one, the standard deviation. These are then validated via loss function that we are using, and then we can get the new amount. This loop is this is how this model is trained. In the process of prediction, here is followed by Monte Carlo simulation, where we feed this Monte Carlo with the mean and the standard deviation, and then we are getting the distribution of the predicted distribution. So given that in our case we have multiple accounts, that means we have multiple time series, then in each time series we can use the covariates, and these time series along with its covariates and were fed in this model, and the training process starts, and we have then a trained RNN model, and we can use it with Monte Carlo in order to get the probabilities. A major challenge that we have to face is the cold start challenge. That means that we have a new account or an account with very few transactions. We cannot have any information, historical information, in order to use it to predict the future runs. That's the reason that we have used the threshold that was set to 10 transactions, so we can make predictions for an account that it has already made 10 transactions per category in order to be able to make some predictions for them. Furthermore, in order to leverage this type of models, we have to use a custom padding technique in order to create time series with the same amount of time steps. Other decision that we have to make is if we have to resample the data. We saw that if we resample the data in terms of weeks, the time frame of weeks, we can keep both the information needed in order to predict future values, and we can, let's say, cover the demand to the SMEs needs. To do that, here is we are creating a starting and end date in order to create, as we said, an equally sized data frames, and here we are grouping our transactions by the account key and the master category. As we said, here we should create per account, per category, a new time series. That means we have to group by our transactions using these two features, and we are using the equally sized data frame, which were added in a list here. This is the first 10 time series. It's the account 128 with category cash, and 188 with uncategorized expenses, and the other, so we can use as title and labels of its time series both the account key and the category of each expense. That process we are concluding with 9,000 approximately time series. So we have to wait a little bit in order to to run this cell. So we have 9,000 time series, more than 9,000 time series, and the length of each time is 204. And we are, as we said, we're using frequency of 1 week. Then we have to set up some parameters, some hyperparameters of the DeepAR model. That is the prediction length. As we said, we are using 3 months. That means 12 weeks. And the context length is in each step the size of the historical values that will be used in order to predict the next one. So you are using 24. These values were also hyperparameter optimization. Then we are creating the dataset in the format that can be used by the DeepAR model, setting the target, the values that we have to predict, also adding these covariates, as we said, the day of the month, the day of the week, and the month. And this is the test set, is the one that will be used for trainings, for testing the datasets, the results. So here also have some other parameters. Again, this can be, as we see, we are using 5 epochs in order to train this. So we have to wait a couple of minutes in order to this model to be trained. Here we can see getting less and less. That means that the model learns something. Of course, here we should avoid overfitting. This is the function that DeepAR and Gluon time series uses in order to make the forecast, to extract, let's say, the forecast for the model. It's getting the predictor, the trained predictor, and the test data, and the number of samples. You can use it 100, 1000. We are using normal distribution, so that will not have great impact to our results. When we said that we have a probabilistic model, that means that the results will look like something like that. We are getting this is the historical values, the one that we used for training. Predicted mean values, let's say it's the blue line, and the green line and the orange line is the upper and the lower confidence interval. In case we are using the 0, the 95 and the 95 confidence interval, the predicted value, and this is the 95 confidence interval of our predictions. As we can see, we can catch most of the transactions, but as we can see, our model does not predict quite good, as in many cases the transactions per category are very few. So that's the reason. We will see later that we have created time series not per category, but using all expenses as a whole time series for each account. But before that, let's have a short discussion about our evaluation tactic. We used the one step forward mechanism in order to evaluate and validate our results. So we have split the data in batches, and let's say for the first model we are using the number 1 batch as training, the orange one, number 2 as a validation, and the test set is the red one. Then we are moving each batch one step forward and to make the same predictions, and finally we are getting the average value and average score of all these steps. In our case these steps were 50. This is more or less the results that we got from DeepAR regarding this this model. Quite interesting takeaway. As expected, the seasonal error of the subscriptions and donation category is the lowest. That means that we can predict the subscriptions which are periodically that happened periodically, and the insurance as well, so we can predict them with confidence. So then we just do the same approach, but just by grouping the accounts, so getting the time series per account and not per account per master category. That means we will have less time series, only to 2,783. But as we can see, then the process is the same. The hyperparameters were the same, and but the results, as we can see here, are seem more clear, and maybe can catch the next transactions in a better way, as we have more transactions and can catch pattern of behavior of an SME regarding considering their transactions in a better way. So that's from me. Thank you very much. I hope that you have enjoyed this tutorial, and see you soon.